Welcome to Climate Conversations. In this show, we're discussing the carbon dioxide forecast for 2025. In a moment, Alex Burkill will be talking to climate scientist Professor Richard Betts. Firstly, some context. 2024 was the warmest year globally. This wasn't just a one-off event, it's a worrying trend. The past decade, from 2015 to 2024, has seen the 10 warmest years on record. For the first time, we've experienced a calendar year where the global mean temperature exceeded 1.5 degrees Celsius above the 1850 to 1900 average. This threshold is critical as it marks a significant point in our climate journey. There were a number of interrelated factors. High sea surface temperatures were one of the biggest drivers of last year's record warmth. Even after the El Niño event eased, many regions continued to experience unusually warm seas. In 2024, we saw record-breaking marine heat waves from the Mediterranean, North Atlantic to the Indian Ocean and Pacific. Oceans absorb most of the heat that builds up in the atmosphere, so marine heat waves are expected to intensify as climate warms. The polar ice retreat continues. In Antarctica, the ice sea extent reached record or near record low values for much of 2024. Arctic sea ice is also declining rapidly in both thickness and extent, further exacerbating the situation. During 2024, the sea ice minimum extent was one of the lowest in the satellite record. Less ice cover reduces Earth's reflective surfaces, which in turn allows more heat to be absorbed by the sea and land. Climate-driven extreme weather in 2024 brought severe storms and floods, heat waves, droughts and wildfires, affecting millions of people across the world. Last year, the Americas experienced some of the most severe wildfires. Large wildfires also returned to the Arctic Circle in June 2024 and September of Portugal. The intense heat not only raised temperatures in these regions, but also led to higher carbon emissions released into the atmosphere. The total amount of water vapour in the atmosphere reached a record high in 2024, about 5% above the 1991 to 2020 average, and significantly higher than in 2023. This abundant moisture amplified the potential for extreme rainfall events and added greater human heat stress during heat waves, evident around the world, most notably in Southeast Asia and the United States, where extreme heat waves brought temperatures in excess of 45 degrees. Last year's record global temperature is largely due to rising concentrations of greenhouse gases in the atmosphere, a consequence of human activities. In 2024, carbon dioxide concentrations reached record levels. The weakening of Earth's natural carbon sinks, such as the Amazon rainforest, added to the rise. Also, warming oceans have less capacity to absorb and dissolve carbon dioxide. This allowed greater volumes of CO2 to remain in the atmosphere. Each small increase in global temperature heightens the frequency and intensity of extreme weather and degrades these vital carbon sinks further. The Met Office outlook for 2025 suggests it's likely to be one of the 3 warmest on record globally, following close behind 2024 and 2023. This trend underscores the urgency of reducing carbon emissions to mitigate further warming and its devastating impacts. Now over to Alex.
Thanks very much, Claire. So now I'm joined by Professor Richard Betts from the University of Exeter, and here at the Met Office, he's head of climate impacts research. Richard, we're going to be talking about CO2 levels, but most of us know that we want to be reducing our levels of emissions, but what are your top tips for doing that?
So one way you can do that personally is to make different choices on transport. For example, this is something I'm very passionate about. A lot of people will drive a lot, of course, and often that's needed. But in many cases, you can choose public transport or to cycle or walk and so on. And often I found it's easier than you might think. I've not had a car myself for 5 years, although it was a little bit of investment initially. I'm healthier than I've ever been, fitter and so on. So that's one way that you can do that.
And there's the benefit then.
Exactly.
It's not
Yes.
just the benefit to the environment, but also the benefit to yourself.
Exactly. So there's a win-win there. You can also make choices about where you get your energy from. Have you got a green energy supplier, and so on. That's becoming increasingly important. And also different sources of energy. A lot of people are installing heat pumps and so on, which means you can use electricity for your heating when you can then choose to get your electricity from a green supplier. But it's also important to say it's not just about what we do personally, it's also about what the system does as well. So it's all very well having a heat pump and getting your electricity, getting your energy from electricity, or it's all very well wanting to cycle and so on, but the system needs to facilitate that. You need safe cycling paths, you need electricity to come from green sources.
That's really useful advice, thank you. Now, your report looking at CO2 concentrations looks both at 2024 and also 2025. So what were the findings and what are the indications?
Yes, we've looked at what's happened in the last year and also what's going to happen in the coming year, because this is primarily a forecast of what CO2 rise is happening, but we also like to check our forecasts against past data as well. So last year, 2024, at the specific place we make our forecast for, we make a prediction for the Mauna Loa Observatory in Hawaii, which is the longest running record of CO2 in the atmosphere, carbon dioxide. So it's very iconic. So what happened there last year was that they saw the largest rise on record from one year to the next. And what we're predicting for the coming year is that the rise won't be quite as large, but still too large to keep us on track globally, the world, with international targets to limit global warming to well below 2 degrees to 1.5 degrees. So it's very sobering findings.
So CO2 concentrations aren't just rising, the rate at which they're rising is going up.
Yes, they've been going up over decades, in fact. They go up faster and slower slightly from year to year, depending on what's happening in the world. Things like wildfires can have an impact at a particular time. But on average, they've been going up. But they need, and they've been going up faster and faster, actually. But the rate of rise needs to be slowing, and ultimately, it needs to come to a halt. And then the rise needs to become a decline. CO2 needs to start coming down in the atmosphere rather than building up.
So how exactly is CO2 measured?
So it's measured in different ways. You can measure it at a particular point, like at a research station, a measurement station, like at Mauna Loa, with an instrument, or you can measure it from satellite as well. But the principle of both is similar. Basically, CO2 and other greenhouse gases absorb light at certain frequencies. So imagine the rainbow represents different frequencies of light, different wavelengths. Those are absorbed in different ways by different gases, and greenhouse gases absorb them at certain wavelengths. So if you shine a light through some air, you can see how much CO2 is in there by how much of different wavelengths of light are picked up on the other side.
That's amazing. That's not the way I would have imagined that people would have measured CO2. Now you have a graph here. Could you tell me what it shows?
So the graph we're looking at is the iconic Keeling curve graph starting at Mauna Loa in the 1950s. So this was the longest running record of atmospheric CO2, and it shows that CO2 has been building up over the years and over the decades. And not only has it been building up, it's been building up at a faster rate. So it's in the last 5 years, and the last 10 years, it's been building up much faster than the 1960s when these were first being produced.
And so why is the Keeling curve so vital for understanding climate change, and why is it different to global carbon emissions?
So it's vital for understanding climate change because CO2 is the most important greenhouse gas that we are emitting to the atmosphere. So it's a key driver of climate change. Greenhouse gases trap heat radiation emitted from the Earth's surface, and that's what's causing global warming, basically. Tracking that is letting us see how we are influencing global climate and driving global warming. This is different to emissions because emissions are what we are putting into the atmosphere. The Keeling curve is about concentrations, the amount which is in the atmosphere. And this is important because once you emit carbon to the atmosphere, a lot of it stays there for a very long time, many, many decades. Some of it is taken back out by natural carbon sinks, we call them ecosystems, so forests and so on. As they grow better, they take some of the CO2 out of the atmosphere. The ocean waters absorb some as well. So it's kind of the emissions drive the rise in concentrations, and that is partly offset by these natural sinks. But what we need to know is how CO2 is actually building up in the atmosphere.
So you talked about these carbon sinks. Could you tell us a bit more about how they work?
Yes, so one thing is ocean waters will absorb CO2, so it's just taken up into the water, and some of that is then taken up by plankton and so on. On land, trees and other plants, they grow better under higher CO2. So when you look at a leaf on a tree, or you look at blades of grass, that used to be carbon in the atmosphere. People sometimes think that when your grass grows or your tree grows, it's actually growing up from the ground and taking up stuff from the ground. It's not. It's actually absorbing carbon from the atmosphere and turning into solid matter, which is the leaves. So as your tree grows, it's physically being built by taking carbon out of the atmosphere. So as your forest becomes more lush, for example, as the trees green up in the spring, they're actually taking CO2 out of the atmosphere.
Well, most people know that, the more trees, the more plant life there is, the better it is from that point of view. But I don't think I fully understood that that's how it's taking it from the air and growing up in that way. So that's fascinating. Thank you. We talked already about the fact that the rate of CO2 concentrations are accelerating. And what are the main reasons behind this?
Increased fossil fuel emissions, basically. We've been burning more and more coal, oil and gas over the years. And that is still ongoing. Obviously, we need to be reducing that globally to slow global warming and ultimately to stop global warming. The aim of the Paris Agreement is to limit global warming to well below 2 degrees above pre-industrial, ideally to limit global warming to 1.5 degrees above pre-industrial. But we're not on track for that yet. There's other contributions like land use change and deforestation and so on also adds to that as well, but the main driver is fossil fuel burning.
And things are improving, but not improving quick enough.
That's right. We are still emitting greenhouse gases to the atmosphere, still burning carbon, and the emissions are still going up. They're not going up as fast as they used to, but they are still going up globally. And the other thing that's happening is the year-to-year changes are also fluctuating in response to climate change and also year-to-year climate variability as well.
Talking about year-to-year climate variability, how do events like La Niña and El Niño impact CO2 levels?
So they have an important impact on changing the rate at which CO2 levels in the atmosphere go up year to year. So the ongoing rise in CO2 in the atmosphere is driven by mostly fossil fuel emissions and a bit of deforestation. But year to year, the rise goes faster or slower depending on whether there's an El Niño or a La Niña event. So an El Niño event is a phenomenon in the tropical Pacific. You get warmer waters in the Pacific Ocean, and that disrupts weather patterns around the world. And one of the big factors there is causing hotter and dry conditions in the tropics. So that means the carbon sinks in the tropics, like the Amazon rainforest, absorb less carbon that year because of the hotter, drier conditions, and often more wildfires as well. So you get an extra kick of the CO2 rise because of that. In La Niña years, when you get cooler conditions in the Pacific, you get the opposite happening. The tropical carbon sinks become stronger, so the CO2 rise is still happening, but slower than average. So it fluctuates year to year, even though we're still seeing an ongoing build-up.
I suppose that all those things you take into account, and that's why you look over such a broad period, which is why the graphs that you've shown go back so far, and that's why that information is so vital.
Yes, exactly.
Because year-on-year discrepancies might otherwise disguise an issue.
Yeah, the important thing is to look at the long-term trends, but also we want kind of early warnings of whether the trend is changing direction as well. So that's why giving this attention year to year and understanding exactly what's happening year to year is important.
Now, you mentioned wildfires a couple of times. The interaction between wildfires, climate change, CO2 emissions, it kind of works both ways.
It does, very much so, yeah. So the events we've seen in Los Angeles, horrible events we've seen there recently, the risk of wildfire in Southern California has been increasing because of climate change, and elsewhere in the world as well. Many parts of the world are seeing a longer fire season, what we call fire weather, so hot, dry conditions. That's been increasing over much of the world in recent decades because of climate change, particularly in Western North America. So more fire as a result of climate change, unless they can be brought under control and so on. So more fire risk at least. But but also that is adding to climate change. So fires, when you burn vegetation, that releases carbon to the atmosphere, and that can be a feedback on climate change as well.
So they keep getting worse and they make it worse as well, which is
Exactly.
so just the problems are ongoing and
Yeah.
difficult to resolve. Now, going back to your research, within the data, were there any surprises?
Yeah, so one of the big surprises last year actually was that although we'd predicted a large rise last year because there was an El Niño event last year, and we predicted that would cause an extra large rise, and we had thought that it could well be the largest rise on record. It was indeed the largest rise on record, but by an even greater margin than we predicted, actually. The observed rise at Mauna Loa specifically was faster than we predicted. The global rise was kind of in line with our prediction, but the Mauna Loa rise was even greater. And that's because we think because there were many fires in North America as well last year, as well as in South America and other parts of the world. So there was not only the El Niño having an effect, but other effects as well, adding this extra kick on top of the fossil fuel emissions.
So with that in mind, where do you see 2025 going?
So 2025, we may see a bit of respite from these kind of climate impacts on the carbon sinks. 2025 may be a slightly cooler year than last year. We're now in La Niña conditions now, so that seems to be likely to increase the carbon sinks and perhaps slow the CO2 rise a bit. CO2 will still build up, but perhaps not as fast as last year. That will still be building up CO2 in the atmosphere, but unfortunately it's still going to be too fast to track where we need to be if we are going to be limiting global warming to 1.5 degrees. The IPCC, the Intergovernmental Panel on Climate Change, creates these scenarios which look at where emissions and concentrations need to go if we are to limit global warming to 1.5 degrees without overshooting it at all. And that scenario, or those scenarios, require the buildup of CO2 to be getting slower already and coming to a halt in the 2030s and then going into decline. But as we discussed, the CO2 rise is not slowing in the long term, and even this slower rise expected this year is not slow enough to track this 1.5 degree scenario.
So do you think it's likely that we're not going to meet those targets?
Well, that depends on many factors. It depends on whether we really kick in on drastic emissions reductions. I think, to be fair, most people are wondering whether this is really possible now. It ultimately depends what the global policy community and global society does. So in theory, we have a choice, but in practice, the options are starting to really kind of be closed off. And these scenarios, which the IPCC have looked at, which lay out whether it's feasible or not, these are now being exceeded. So we're kind of looking at even more extreme cases than would be in those scenarios.
And why are we struggling to reduce these CO2 levels?
The CO2 levels are difficult to reduce, partly because once CO2 is up there, it stays in the atmosphere a very long time. Even if you reduced emissions now, even if we cut emissions to zero, the carbon we'd already emitted would be staying up there for decades and in some cases centuries. So that's one way in which it's hard. But then of course there's the kind of challenge of reducing emissions themselves as well. The whole economy of the world is so locked into fossil fuel use that it's very difficult to get out of that. There's progress is being made in getting away from that, and the UK has been reducing its reliance on fossil fuels for energy, for example. But we're not, as an international community, getting away from fossil fuels as fast as we should be to stay on these IPCC and international targets.
Thanks so much, Richard, for taking the time to go through your important work. It's fascinating how we're tracking CO2 levels and also alarming to many extents. Thanks also for Clare Nasir for the help with this month's Climate Conversations. We will be back again next month, but for now, I'll say goodbye. Thanks for watching. If you need any more information about the work that Richard's been carrying out, then do check out the links in the description. See you later.